Okay, so today what we're going to talk about is the average rate of change of a function. You might remember this as slope. I think back in algebra, you knew what slope was. Slope was a constant rate of change. Now, what did you see that as? You saw it as a formula. The formula that you probably saw was y2 minus y1 all over x2 minus x1. And then some people might have did delta y over delta x. Now, why would you do that? Delta means change. Delta means change or the difference. So either one of these means the exact same. So a constant rate of change is slope. Now, when you talk about a function, so slope happened with a function like linear stuff, but you can actually talk about what's called the average rate of change. Here we have a function right here. It looks like some sort of polynomial, just a little snippet of it. There is different rates of change along this entire curve. It's not constant, but what you can do is you can find what's called the average rate of change. And the average rate of change between a certain interval. So in this case, if we went from here to here, from A to B, there is an average rate of change from here to here. It looks like the curve is going up. But what the average rate of change is, it's this green line right here. The average rate of change, the average rate of change is the slope of a secant line. Now, I don't know if you got to sync it. It's the slope of a secant line through 2 points on a function. Now, I don't know if you got to secant, but secant means to cut. So essentially it cuts it into two parts. So that's what you're finding. All right, that's what you're finding. So now when you use how you find the slope or how you find the slope of the secant line or the average rate of change, that's what this guy is right here. This little formula right here is actually the slope of the secant line. It's the slope of the secant line. It's f of b minus f of a all over b minus a. That's how you find the slope of the average rate of change of the slope of the secant line. So let's look at it. Here we have a parabola, right? We have a parabola right here. If I pick, if I want to say I want to find it on the interval from -1, 1. What does that mean? That means I'm going to take this point right here, and I'm going to take this point right here. At x is -1 and x is 1. What can you predict the slope of this tangent line or the secant line going to be? The slope clearly is going to produce some sort of negative value. So what do? I find the f of b minus f of a all over b minus a. So what is that? F of b. If b would be this guy right here, f of b looks like it's -2 minus f of a, which it looks like to be 0, all over 1 minus a minus 1. So -2 minus 0 is -2, and then 1 plus 1 is 2. So this is -2 over 2, or -1. The average rate of change is -1 on this interval. Now, if we moved and went to a different interval, what if we went to like, oh, I don't know, what if I went from 2 to 3? If I go from 2 right here to when x is 3, which is right here, that slope is probably going to be positive. So what's the slope of the secant line there? So you do f of b minus f of a. So f of b minus f of a all over b minus a. if you do that, let's see, what is f of b? F of b is 4, and what is f of a? Is 0. So 4 minus 0, I found the easy one. So 4 minus 0 over 3 minus 2. 4 minus 0 is 4, 3 minus 2 is 1. My average rate of change is 4 on that one. So that one makes sense. There's lots of applications, but realistically, it is just simply the slope formula, but it's not constant. Constant rate of change is known as slope. So I hope this makes sense. You have some practice problems. I'll see you in class real soon, and may the force be with you.